Hello everyone. Now we are starting with the unit number 6, development of lateral surface. First we'll go with some fundamental things. What are different solids, and based on that we will see what is the lateral development. So we had in the lecture what is the development of lateral surface. So just quick revision of the same. So we'll go through with the first different types of solids. So in development of lateral surface, we have different solids as named cylinder, cone, prism and pyramid. So very common in day-to-day life, you might have seen these are shapes and even your basic geometry also. So let's see what is a cylinder and how its development is obtained. So we'll just focus on first basic introduction of this development. What is the development? So this is cylinder in 3 dimension. I'm trying to drawing this diagram. I'm using a sketch pen to understand and to detail the drawing in the video. Of course you need to use a HB and 2H pencils. So let's see, this cylinder is obtained by some material. So what is the meaning of this development of lateral surface? Lateral means in the lateral direction. Suppose on this cylinder, if I wound one cloth or a paper, its unwinding shape is a development. So we are interested only in the lateral. So lateral surface. So very simple. So this cylinder can be obtained by just rolling this paper in this way or like in this way. So and technically in graphics language we call lateral surface only this, means we are not interested in the top and the bottom face of any solid. So if I wound this rectangular paper in this way, I'll get that cylinder similar. So that is what we say a development of cylinder. But very important, it is lateral development. So only in the lateral direction. Similarly, now this is cylinder development. Now we'll go to second one important solid, that is cone. Let's see how the cone is obtained. Again, as discussed, we are interested only in this curved shape, not on the base. Suppose on this cone surface, if a cloth or a paper is wound, its unwinding shape will be the development. So it's very simple. If I consider this as a generator, this is called as a generator. So if I just unwind this shape, this surface obtained is nothing but the development of cone. So this is development of cone. So I'll get this. Of course, this is the generator length. Now, similar to this shapes, cylinder and the cone, how we obtain this cylinder and cone by wounding some paper or any other material, its lateral surface development we are interested. So these are the two major topics in our unit number 6. Now, of course, we'll discuss these two shapes first. To obtain this development of cylinder, what do you think? What should be the height of this development surface? Of course, which is very logical, height of the cylinder. So this is height of the cylinder. For this development, what should be the length? This length is exactly equal to the, of course, this surface, of course, as a length. So thus we know that this is 2 pi r, or you can say pi d, circumference of a circular base of the cylinder. So for this development, as a rectangle, what you see here, this is a length which is 2 pi r or pi d, and the height of development is equal to height of the cylinder, which is given in the numerical most of the times. Second is cone. So this is very interesting. So when we'll solve some numerical on the cone, so there is an interesting term, this theta. We need to find out the angle. So we'll discuss with the specific values in the numerical. So we'll go in detail the cone later. Second part of the unit number 6 is we are having two important solids as prism and pyramid. I hope you all are able to hear and see what I am drawing here. Prism and pyramid. We are just discussing first basic introduction of development of lateral surface. So prism and pyramid, in many movies you might have seen a pyramid structure. I'll draw some freehand sketch of prism and pyramid here. Just observe. I'm drawing a freehand sketch, of course. So this shape, you can see this, it looks like something, a rectangular block. So we'll discuss and we'll define what is the difference between these two terms, prism and pyramid. Similarly, I'm drawing one more geometrical figure, and with some so of course I'm drawing a freehand sketches to just understand. There are many good videos and animations available. You can search to find out what is a prism pyramid, its development, and there are previous videos. You go through it, you'll understand better in 3 dimensions how the pyramid and prism will look. So it's just recap, fast introduction. Now this is like a difference, you can say, major between prism and pyramid. What is prism? Prism, if you see, we have two. If I draw some here dotted surface, you'll understand quite better. So we have two surfaces. This is, we can say, a bottom face or a bottom surface, and this is a top surface. These two are same in the cross section, and it is a geometry which is joined by using different faces, right? Whereas if you see this, we have some base shape and we have some base edges. I can say base edge. These are base edges. As you can see here, it is a square. So square pyramid. This square pyramid is joined, or we can say it is converged at one point, which is called as apex. So of course, very logical. What here you can see is a face which is triangular in shape. So always we have triangular face for pyramid, whereas if you see these faces, all these are rectangular faces. So if one has a doubt how to distinguish between a prism and pyramid, so very simple. As a pyramid structure, we have a faces which is triangular in shape. Prism is always a rectangular face entity. So of course this is a rectangular prism. If you can have a pentagonal prism, hexagonal prism, and polygonal. Similar we have here triangular pyramid, hexagonal, pentagonal, and so on. Logic is we need to have different, these are edges for the base, of course. So they are connected at one common apex. So with this, we'll see now how the development of prism and the development of pyramid is obtained. So you just go through it once, all the diagrams. I'll review and recap quickly. So we had a cylinder, its introduction and development, how it is obtained. Cone, we'll see, just we had a basic how the shapes are obtained. We'll see the dimension with the example. Prism and pyramid, just introduction, how we can define and differentiate the solids as a prism and pyramid. So we can have n number of example for both. So I can say a rectangular prism, or we can have a pentagonal prism, hexagonal prism, and similar way we can have pentagonal pyramid, hexagonal pyramid, and so on. Now I hope you are quite understood all of the previous concept and this concept of prism and pyramid well, so that we can now focus on how the development of prism and development of pyramid is obtained. So of course we are interested in lateral development of prism. So once you know cylinder and the cone, it is a special case of this, or you can say it is a relevant to this. So let us consider on this surface, I have wound some surface as cloth or paper here, and I've cut this and unwinding this shape. So of course I am interested now in the lateral development. So what is the lateral development of a prism? So what do you think for this solid as a prism? What should be the, let's say I'm looking from this front view, it will look like something a rectangular block, and this dimension and this dimension will be this base and the height of this block, which is quite normal and given in the numerical. For the top view, this is for front view, so I'll use a different color to understand. So this is what you can see in the front. So I have drawn this, and for the top view you can see this face. So I can draw this as a top view. Suppose whatever dimension I am, whatever given in the numerical, I am just representing this image. So its development of prism will be just unwinding this paper. So what we can see here, which is exactly equal to this height of the block. So this, if this, the height of this, let's say prism is 70 mm. So the development height will be 70. And what should be this development length? So very logical, that depends on which prism you are using. So if it is a rectangular prism with the base side 30 mm, then this will be 30 into 4 because it is a rectangular, or maybe a square. We can say rectangle, ideally it means it should have a different length and this 2 parameter. You can say if it is one side is, this is 40, this is 30. So logically it says this total perimeter, right? So if it is a rectangle, you should add all this base length. To make it simple, I'll say a square. Okay, so square prism side 30 mm. So it will take square base side 30 into 4 as of course number of base edges. So it will be total length of your development. So just add those edges. So you can say this 130, 60, 90, and the last one, this edge. So if you give the names here A, B, C, D. So let's say as I have drawn this rough diagram, this same if you say a square, I'll draw here. So of course all those edges are same. So 30, 30, 30 and 30. So consider this is a base, this is A, B, C and D. So A, B, C, D. Again the same edge is going to wrap on the same edge. So it will be again A, B, C, D and the last one is A. If you want to give the name to the top surface, A as this as a 1, 2, 3, 4. So A1, B2, C3 and D4. So 1, 2, 3, 4 and the last one will be again 1. So this is what the development of prism. This is a just basic introduction. We'll go one by one in detail. Just go through and recap some previous topic. If you want to, you can recap and just try to understand how we are discussing the development of prism. We'll just focus now on next topic as a pyramid in few minutes. I hope this is a basic introduction to the development of lateral surface. So where we had a cylinder, cone, prism and just basic what is a pyramid or difference between these two solids. So actually when you will come to know an exact dimension and drawing of these surfaces, you will have a better understanding of all those geometry. So let's start with a very simple and the basic any prism, pyramid and the solid. So I am taking one example to understand and I am drawing by using a sketch pens. So it won't be that precise, but that will clear all your concept. I am trying to use different instrument that what you're using for actual drawing. So let's start with some numerical first. So this is question number 1. I'm just taking a random, not in sequence or easy to hard level. It's very logical also. To understand the different shapes, prism, pyramid and their difference, you can watch a previous video and go through it as how the development is obtained for a different prism and pyramid. So let's start with the example. So in this question, you will see, I'll read question. Hexagonal prism. So always note down what is the shape and type of solid. It is a prism, not pyramid. It's a prism. So we should know it's a rectangular face, hexagonal 6 face. Base side 30 mm. So we have hexagonal prism of base 30 mm and axis is 70 mm. It's resting in HP for horizontal plane, means on this surface you can say. So we have a hexagonal prism which is rest on the horizontal plane or surface. It is cut by, now see, it is cut by a cutting plane which is inclined at 45 degree to HP. So now we have one plane which is 45 degree to HP. Now it is, we'll see the advanced step. We have a problem of this type which will be asked in your exam for 10 marks, which is very important. For 10 marks question, we need not to draw only a development of lateral surface, we have additional condition of cut by one plane. Now, very important, where is that plane? Means angle is okay, fine, 45 degree to HP, but angle is 45, but positioning should be correct, that is bisecting the axis, bisecting axis, which is important condition, we'll see now. And here's the question, draw the front view and the development of lateral surface. So of course you will get this question in your NSEM exam. For this kind of question. So once you understand the concept of any one prism, so all other problems are same, which are very easy and you can easily complete those problems. Now let's start hexagonal prism. Now before to draw this problem, I'll just clear, I'm using a sketch pens to just for understanding. Don't use these pens for your exam. You should use pencil as prescribed. Now a prism as a hexagon. So how hexagonal prism is drawn? So just check. Base side is 30 mm resting in HP. So 30 mm in compass. You take a distance 30 mm in compass. Draw one circle. So here I am using a different colors. In exam you should draw the circle faint because. So this is 30 mm. So 30 mm as radius. Draw a circle in the top view. This is the procedure to how to draw a hexagonal shape in the top view. So I have drawn circle. Of course, this is the center. Now I need to draw a hexagon, which is very simple. Draw one horizontal or vertical, either or. I'm drawing horizontal. I don't have ruler or a drafter here, so I'm using a normal scale. So maybe minor error. So this is first you can draw one reference horizontal diameter. Of course, when you are drawing by using pencil, all this should be very faint. It should not be too much dark. We are interested to draw a hexagonal shape, not a circle. But with this method, you can draw hexagon in a least possible time. Now, keeping your center of the compass at these two ends with the same distance as the radius of circle, because the radius is equal to the side of hexagon. So from this end, mark arc on both the sides, and from this end mark the arc on both the sides. I'll use a different color now. So you got 1, 2, 3, 4 points, and already you have drawn a horizontal diameter. 2 has already 2 reference points. So now join all those 6 points. So in exam, when you are drawing hexagon, what I have drawn by using a black pen, that should be visible and drawn. So yes, this is a hexagonal top view. Of course, we are drawing a front view. So you can give the names like anywhere you can start, but it should be either in clockwise or anti-clockwise. You can give the names. So I'm giving, let's say, A, B, C, D, E, and F. So this is my hexagonal prism top view. Now take its projection in the front view to complete its front view. So I'm just taking a projection. I'll use another color to avoid confusion. But of course these are projection, and you all are now quite aware how to take a projection. It should be faint, light and thin, and very logical. This 2 points C and E lies on the same point. Of course, this I am drawing a freehand sketch, so slight maybe error. So C and E on the same line, this F and B on the same line. So just take a projection. Remember, this is a hexagon and this should be darkened when you're drawing by using pencil. Now, what is the axis height? 70 mm. So of course, locate the axis. This is my center of hexagonal prism. Just draw axis. Now see how I am drawing axis. I hope it is clearly visible in the video. Please let me know if it is not clear so that I can stop and again I'll check. Okay, fine. So now we'll continue. I hope it is clearly visible and you are following me. Now I'll draw this front view with the axis at 70 mm. So I'll mark 70 mm distance on the axis. As it is prism, no problem. It's very logical. This is a point, this is 70 mm point. So what I'll do is exactly parallel, I'll draw one reference line. I don't have eraser for the sketch pen, of course. So I'm drawing very precisely. So this should be the height 70 mm. So draw front view. Now I'll just give some dimension. So this is the hexagonal prism of base 30 mm. So base side 30 mm. So I'm just giving a dimension. We are conducting this lecture to learn the development at home, and of course you can use a basic instrument to draw and practice same problem. So this is a 30 mm base edge for the hexagonal prism. So you can give the dimension for this also. And it is a 70, so you can write 70 like this. Of course you can draw extension line. So yeah, this is the first stage for this development, hexagonal prism. So what I did, I just fastly recap. First, draw a circle with the red color I have shown, with the base, as the base of the hexagon is 30, to take the radius is equal to 30. Then draw one reference, this diameter horizontal. You can draw vertical also, no problem. From these 2 points A and this, draw the radius as 30 mm distance from both the sides. So I'll get this 2 point, similarly this 2 point, and join. From the center, project here, take here 70 mm, project all this edges, you can say, for a prism, and complete the front view. Now here you can see we have C and E. So draw this, and we have F and B. These are the edges, of course, so they are visible in this. Now we are making very clear. I am just showing a prism of ABCD for the bottom face. means the A is the bottom face edge point. Similarly, we have a 1, 2, 3, 4, 5, 6 point. If you want to understand this, I'm drawing, let's say, a very freehand sketch for this. Suppose, to understand a concept, I'm using a square, not other shape, because I'm drawing fastly and freehand sketch. So this is A, B, this is C and D. So this A, B, C, D is the base. Similarly, we have a top face. So let's say A and the top face edge, another point will be, let's say 1. This is 1, this is 2, this is 3, and this is 4. So now this is A1 edge, what here you can see is, right? This is B2, C3, and D4 for a square. Here we have hexagon. So we have A, B, C, D, E, F. As here we can have any shape. So similarly we'll have a notation. So logically you can say A1, B2, C3, D4, and so on. So let's say this is A, this is B and F. So if you want, you can give B comma F. This is C comma E, and this edge represent these two edges, this point, and this is D. So if you want, you can give 1. So of course B2, C3, D4, E5, and F6. So very logical and simple. There is no problem regarding the notation. You can use any other notation too. We are just following the concept. Now I hope you are with me till date. Now we'll just move ahead with the development. Now what is development as discussed? It's just a lateral development we are interested. We are not interested in the top and bottom face, how it will look after the unwinding shape. Now what is this base edge dimension? 30, and the shape is hexagon. So what should be the total perimeter of this development, or what should be the length of development? So you can start from any point. Let's say I'm taking first, this is my reference line. So let's say A is my starting point, starting edge. Means from this I'm cutting here and unwinding the shape. So of course logical, the height is equal to this height, and what should be the length? Length of total development equal to the total perimeter of the base. So as 30, so take 30 mm distance in compass, which I have already taken while drawing this. Check 30. Mark from this reference line, let's say A. So B, and the A, this is B. This is my B point. C, D, E, F, and of course one more, the last, A, because it's a development, so the same edge will coincide with the same edge, right? So I'm using a freehand drawing for understanding and complete this development. Okay, fine. Now it will be visible, right? This edge, even this. So draw this, all the edges. I'll give the name first. A, B, C, D, E, F, again C, A. Now draw the corresponding edges. Okay, yes, this is the development. So of course all it is a development length of this total is as discussed, just mention 30 mm is a 1 this length, as it is hexagon into 6, so that is the total length of development. We'll give the dimension for this. course it is, all dimensions are in millimeter, so no need to write. Now, very important thing, this is what just lateral development, but question is being cut by one cutting plane which is inclined at 45 degree to HP, bisecting the axis. So I'm interested, I'll just explain the first basic. Just consider this case. Now we have one plane which is, I'll use another color. First try to understand what is that, what is the concept behind it. So now this is the plane which is cutting this solid. Of course this is in 3 dimension. So we are interested when any plane cut this solid, how its development will look here, and of course the surface of development. Suppose as it is a square, so 1 2 3 4, this is a normal development. When it is cut, so this cutting plane will cut different edges of this prism, and this is, let's say this is a height. So this height, one edge, this is a height, we need to transfer somewhere on this development, on of course respective edge. So it will be somewhere like this. Of course this is a straight edges, not curve. Means let's say this is A1, this is A, this is 1. So when I wind this shape again, in clockwise, anti-clockwise, whatever, we should get the same surface below to this plane and above to this plane. So we are now interested in this intersections of points. How these points, and very logical, on this A1 edge, where is this point? Of course this is a point which cutting plane cuts the corresponding edge. Similarly we have B2, this is another edge, another point, and so on. So this is a very logical. We'll see for this our case. I know I'm drawing very now we'll focus on a development of this surface with cutting by some plane. As mentioned here, we'll draw one cutting plane. Angle is 45 to HP. Important. Where to draw that plane? I can draw, let's say this is a 45 degree angle. I can draw anywhere, right? So everybody answer will be different. No. So they will mention condition. Where is the plane? Plane is at bisecting. They can give any position. Let's say 10 mm from base, 50 mm from the top face, or the mid of this. Of course that is the meaning of bisecting the axis. So this is my axis 70. Bisecting means it's midpoint. So I'll take a 70 midpoint. So this is my midpoint of this prism here. And now take this D and take 45 degree angle here. Keep your 0 here. And from this 0, 10, 40, this is 50. You can see clearly 40 to 50. 45. Join and locate this plane. This is for reference, of course. You should have a plane which is exactly at 45 as well as which bisect the. I hope it is clearly visible in the video. Please let me know by texting and messaging if it is not visible, or if you face any problem, I'll check. Now I've taken this as a 0 reference at the mid, means this distance is 35, this is 35, because question is bisecting axis. So this is my 45 degree point. Now draw a plane. Okay, this is of course 45 degree angle. So this cutting plane angle with HP, means horizontal plane, anywhere if you can check, that is 45 degree. Anywhere you can write this angle is 45 degree. Now this is cutting plane. Now this cutting plane cuts this prism at different edges, at different location. So let's check one. This is one edge of the prism, and this cutting plane cuts at this point. I don't want to give a notation that will make it very complex. You can use any notation. Just try to understand concept. Similarly, this cutting plane cuts another edge of the prism. This is B2 and F6. What you can see here, same. Of course, we are not interested in axis because this is a three-dimensional. Axis will be somewhere here. So we'll just check the edges of the prism where it cuts. This is C3, E5, two edges coinciding, and cutting plane cuts at this point, and this is D4 and the point is here. Now, what do you think? How the development will be visible in this section? Now, A1 edge cut by this cutting plane 45-degree angle. Now this point I need to transfer on, of course, corresponding edge. So A1 will be transferred on A1 edge. So you can give the name A1, 2, 3, 4, 5, 6. Again 1, A1. So just, now it's very simple. Just take a projection. A1, this is a point of intersection. Transfer on the A1 edge. That's it. I'll use different colors. So this is first. So this is the first point for this development. Similarly, these are the two edges B2 and F6. So of course this you need to extend up to B2 and F6. So this is B2 and you can just, I'll use different colors. In exam also, you just need to show a projection properly. So this is my first point. Let's say 1. You can give any notation 2. This is on the 6, so I'll say give 6. This is for my convenience. You can use any other notation also. Development should be correct and same for everyone. We are not interested for this axis. Now this C and E, of course C3 and E5 intersection point is this. So project here. This is C3 and E5 again. E5, right? So 3, 5. So 1, 2, 3, 5, 6. What left is 4. Okay, so this is D4. It's coming very near to the base. Take a projection up to D4. Yeah, so this is 4. So I got all the points. 1, 2, 3, 4, 5, 6. What about this? A1. Of course, same edge, same point. So you can take projection and mark here, or you can take same distance in compass. What you can do, you can take this distance in compass, you can mark here. I'll use only another color to understand what else I can do. In exam, the projection should be visible, of course, but it should be very light. That's your line work. Yes, done. That's your 10 marks. Just join all those with the, as it is a prism, edges, the straight line. I'll use now which color? Red. Okay. 1 to 2, 2, 3, 3, 4, 4, 5. Join by a straight line. Last one. Now yes, this is the development A1, 2, and this is what you can see after cutting the hexagonal prism by a cutting plane at 45° to HP and bisecting the axis. So this surface you can see. If you want, you can make this line also with the same brightness, or you can darkness, you can say, meaning exam. these lines, red color lines, and this 1A and this surface should be dark. So this is what the development, this surface is development of lateral surface for hexagonal prism. I hope you are following me now. Just go through it, recap if you want, recap and check it. This is a hexagonal prism. So any other shape also you can draw, pentagon, square. They are very basic and simple than this. So this is the hexagonal prism development. I have drawn hexagonal prism first and its development. This is the first lecture, introduction, where we had cylinder, cone, prism, pyramid concepts, and we started with introduction and we have solved one problem. I think it's sufficient for today. This is a 10 marks problem where these dimensions are very important. You can mention here this angle theta as 45 degree. So 10 marks distribution is roughly, not exact, but it carries 3 to 4 marks for this, and rest of 6 marks measure is for the development, where this point should be correct and with the very good line work, which indicates actually as it is a video part, so I am using a sketch pen with different colors. In exam, only this hexagon, which is black color what I have drawn in the top view, this surface and this part, red, and this bottom face should be little bit dark, more dark. So that indicates a good line work. These projection lines should be lightly drawn or very thin and faint. So I hope we'll stop today. Please let me know your comment and how it was first session so that next lecture can be improved. I'm trying my best to utilize all the resources what I have today, and please let me know in the comment section how it was today's session. Tomorrow we'll be dealing with the pyramid, cone, and the cylinder development, which is little bit different problem from university. I mean, that can be asked in university papers. Of course, this is the same question that can be asked for 10 marks. So very important, as it will take hardly 20 minutes to draw if you use a proper drafter or actual instrument. I hope we'll connect soon for tomorrow's session, or it may be a next session. Let me know in your chat and comment box your feedback. Thank you.